This is Aspen Pittman coming to you from Aspen's Place Recording. And I have my friend James Abke here today, and he's brought in his ViPre preamp. James had asked me if I could give him a little tutorial on it. I did this for years at trade shows, and I haven't done one for about 6 or 7 years, but I thought that while I was doing it for James, I might be doing it for all of you that have a ViPre out there, and maybe you've got one, but you don't know all the bells and whistles and how it works and why it's such a cool preamp. We have, how many we got, Brian? We must have like 7 or 8 of these in our big racks at Aspen's Place Recording, a 32-channel all-tube recording studio, direct to Pro Tools. And we love what Pro Tools can sound like if you give it all tube signal processing. I think it's a misnomer that digital recording is cold. I think it's an more accurate way to say it's neutral. So if you have something that's, and it's very revealing dynamically, and if you have a very hot solid-state mic or a hot solid-state preamp with op amps and FETs, it can sound harsh. It can sound brittle. And you might be reaching for a compressor or a de-esser. And when the real problem is the actual preamp itself creating those issues because of the component of the preamp. Now, a ViPre, which was kind of our flagship process in the day when we make these, we no longer make them. It was an all-tube preamp and with a fully differential balanced signal path. Now, most preamps that say they're a tube preamp have a tube in there, but maybe they've got a little something else, and the tube is pretty much a marketing device. But even if they are an all-tube preamp, I would say probably 99.9% of them are not a balanced mic pre. Now, a balanced mic pre might be just balanced in, balanced out, but since the preamp is after the input and before the output, it would be more correct to say a balanced preamp would have a balanced signal path. In the old days of recording, pretty much everything did. That was the secret way to get a very low noise, low artifact type recording, a lot of air, because balancing is a very fundamental part of audio engineering. And what it really means, I guess the easiest way to understand balancing is pretty much all mic cables have 2 lines that run down a cable, and any noise or spurless oscillations, electromagnetic fields, radio stations, whatever, that gets picked up along the wire on the way. When we flip it out of phase at the other end because the interference came in as positive on both lines, when we switch it at the other end and we throw them out of phase, they get canceled. That's called common mode rejection, generally speaking, and it eliminates all the hash and the noise and the problems. Now, when we're building preamps, and in the old days, the original consoles and pretty much from the microphone to the recording head where you made your record, it was an all fully differential, balanced, and floated signal path. That means from the mic to the pre, from the pre to the compressor, from the compressor to the head amp for apps on the recording head amp, for the cutter, or the tape deck, all balanced all the way through. We got away from that. Balancing, just like this cable, takes 2 wires to go down there. It's double the cost of 1 wire, right? So if you had a preamp or a compressor or any component in your chain, you had to have 2 tubes instead of 1 to do the same job. 1 on the positive side, 1 on the negative side of the balance, the floated line, so that ViPre is built in that old school way. A lot of people cut up those old preamps just to get a channel out of it because it has a certain characteristic of sound. Mostly it has a tremendous common mode rejection naturally because of the physics of its being fully floated and balanced. And it is probably the reason we like those old preamps, and it's certainly a reason why you're going to like your ViPre and why we use them here, because if you don't have that, if you're a typical mic preamp that's a balanced in, balanced out, and then you're single-ended in the middle, just like a guitar wire will pick up noise and you can't run it past so many feet without problem, you've got all kinds of oscillations and wires running past wires and gain stages. You've got a big transformer in most of these preamps emanating electromagnetic fields. So how do we get rid of all that noise? Well, we put Band-Aids over it as a designer. We use resistors and capacitors in the circuit path, and we kind of neutralize things as we go, as we trace the circuit, and we basically cloud up the box, which should be a very simple signal path with a lot of extra garbage, Band-Aids, to get rid of all that noise and hash and hum, and then we have to rearrange things, how they sit in the box, and we go through all this trouble, and at the end you don't get a lot of air out of the signal path. So an original balanced signal path does provide a lot of air. Well, ViPre is a fully differential floated signal path. It really is a balanced mic preamplifier, not just an input and output stage. It's balanced and single-ended. So it's got twice as many tubes as we would need to do the same amount of job. It's literally 2 mic preamps in one, thrown out of phase. And then when you get to the other end of the output, we throw them out of phase again, and that rejects everything that happened to the signal path all the way through. It's old school. It's very expensive. And one reason, as I will point out, we use 5 decibel and 1 decibel gain steps over here is because we're using switches on the other side of that. An actual potentiometer can't give us a perfectly balanced between the 2 signal paths. It's a wiper. These are switches, so they exactly stay 180 out of phase at every stage. So we have a 5 decibel gain stage over here, and we have a 1 decibel gain trim over here. And again, very complicated switches. On the back of these 2 knobs, you're going to see switches with anywhere from 4 to 6 decks with hundreds of resistors soldered by hand at every step. And when I flip this 5 dB up, both signal paths are being flipped 5 dB up. So they have to be very accurate resistors, or 1% resistors. There's about 256 hand soldered connections on just one knob, as opposed to just soldering in one pot to go up and down. So the complexity that this brings and the expense that it brings to the project is significant. One reason we got away from all that in the 70s. And of course we got away from tubes as well. So this is a tube preamp. It's an all tube preamp, and it's fully differential and floated and balanced. Now the 2 things that a mic preamp does, and it might sound obvious, but it loads the microphone and it amplifies the signal. Those are the 2 things we're going to concentrate on the demonstration today. So the loading part is pretty much where we get our ViPre name for. That stands for, it's an acronym for variable impedance preamp. Impedance. Impedance is the way we load the microphone. And in the old days, the microphones used to be 50 to 100, 150 ohms, maybe 200 ohms. There's still 200 ohms today, but they would hit a preamp that was basically designed for them. And of course, in the old days, people were well off the microphone. Sometimes they were over an orchestra, so the ballistics of a close mic wasn't a problem. And so the preamps were typically loaded at the right impedance from the output of the mic to the input of the preamp, and then from the preamp to the next stage, and the next stage finally to the, if you're going to use a compressor or an equalizer. Always kept it fairly low, and mostly when you load the mic, that's the most important place to load and where you really hear a difference. So as we progressed in our concept of electronics, we tended to make a rule. We had rock and roll came along, and all of a sudden things got a lot louder in the microphone, and we didn't want to overdrive them. So what we did is we started having higher load impedances, and the rule of thumb was 10 times the source. If you had a 200 ohm microphone, you probably wanted a mic pre that loaded at about 2,000 ohms or higher. It's very typical today. And the problem with that is that you don't get as much energy out the mic. You have to amplify the energy, which creates more noise ratio. Not a big problem for solid state stuff, but it was a big problem in those days for tubes, because every stage of tube, by the nature of a tube, the one downside is it has a heated filament, and heated filaments create noise. So the more tubes you have in the signal path, the more noise you have. So they were trying to keep the noise down, and therefore they kept the impedance down. So we got more natural output of the microphone into the microphone preamp. More natural gain. We didn't have to make it up. And so right now I've got ViPre. You notice it has an input section. This is where we can change and we can vary the impedance of how we load the microphone. And I'm just going to show you with the headphones on, and now we're recording into a Pro Tools rig, which I never did before. This is something kind of new. I think you'll be able to hear. the differences this mic makes. Now, the mic I'm using is one of our least expensive mics that we produced. It's an FET. It's not a tube mic on purpose. I wanted to use a solid-state mic, and it has a large diaphragm, and it does not have the disc resonator. So it's a natural large capsule that would be typical of what you'd see in a U67, a U87, a FET mic, and it has a Class A FET circuitry in it. And that's what we call our Model 1B. And again, this was a mic in its day that sold for $300-400. It's a good sounding mic. It's a 3-micron diaphragm, but it's not an expensive mic. The idea behind a ViPre is we can take any mic and make it sound expensive. That's what a mic preamp should do. If you plug a cheap guitar into a nice Fender amp, it sounds a lot better than plugging it into your hi-fi. And that's the analogy I would like to use as we go through here. We're going to take a relatively inexpensive GrooveTube mic. We're going to plug it into there, and I'm going to show you the difference. Now, a balance bridge simply means we're going to the first tube. In the case of a preamp that wasn't tube, we'd be going to the first op amp, or we'd be going to the first. And that's where we get our first lift of gain. It comes out at a very low level, and the input loading on most of these today is in the several thousand ohm range. Most microphones in there in several hundred ohm range. Most mics' typical output impedance about 200 ohms. So we're observing that 10-to-1 ratio right now. We're going into something that has about 2,400 ohms of load impedance on the microphone, and you can hear it sounds pretty good. What we're going to show you is how much better it can sound as we start to bring that lower. And then right now, this is what they call a differential input. It's an electronics input. In most preamps, you don't use transformers anymore. Maybe you know that if you had a Neve console with transformers, it would be a lot more expensive, because transformers are very expensive. Transformers are going to do the job that this electronic circuit is doing right now. When I go to a balanced transformer input, I'm going to actually be loading the microphone with about the same impedance, but a transformer reacts to the microphone a lot differently than an electric circuit might react. So you're going to hear the difference when I just go over here. It's 2,400 ohms, and I'm going to go to a transformer. Now, you notice something happens on the transformer, and all of a sudden, I don't have to be right on that microphone for it to reach out and grab me. Why? Because the transformers are a friendlier input, even at the same impedance, than a solid state or a tube would even be. So I'll go back again. This is the balanced bridge, and you see it's very accurate and a little bit dry, but the minute I hit that transformer, wow, it starts to really open up and get a little soft and warm and fuzzy. Now, a transformer, as you might have had in a console in the 70s, which is pretty much when they started coming out of consoles, and by, again, a transformer per channel could be as much as $200 for a good Jensen transformer, versus a few dollars for a little op amp or a little FET balancing circuit. But a transformer has another neat feature, and that is it creates a certain isolation characteristic that you don't get in electronics. It literally creates an isolated input, which it's a handy thing to have in a studio with a lot of stuff going on. And then if you were to go to a transformer in an earlier board, let's say from the 60s, more likely you'd be seeing a 1,200 ohm input. Now notice every time I went from 1,200, and I can go back to that balanced bridge right now, or I can go to the 1,200, the microphone's going to reach out and grab me. I'm now about 1.5 feet away from the microphone, 18 inches roughly. If I went back to a balanced bridge, I'd be pretty dull sounding. So it does allow the microphone, I call it reach. It just reaches out and grabs a little bit. Now I can get into the microphone, and I can actually kick up 5 dB, but it's not the same characteristic that you'd get by actually going to a 1,200 ohm input loading balanced transformer. As you can see, it kind of goes right down the throat and grabs the tonsils, and so to speak. Now, if you want to go back to the 50s and beyond, we commonly had input transformers that were 600 ohms and even 300 ohms. Now, 300 ohms, I can be a good 24 inches off this mic, and I can speak very softly. I can even whisper, and it sounds like I'm right in your face. And I'm not. Now, if I go back to the balanced bridge and I take the balance microphone off at 300, that's the range. I'm back to a balanced bridge now. I have to get way up in here to get that kind of up close and personal. So you get a lot of free gain with the transformer. It'll come back here. That's just going to 300 ohms. And I'm going to go back to 600, 1,200, and 2,400. I kind of call that the Wayback Machine. so you can emulate earlier recordings, especially ribbon mics, which really blossom with when they're loaded at 300 ohms versus a balanced bridge. So you can go to 300 ohms, or I can go to a balanced bridge. You can really hear I've got about a 5 to 8 dB step there. That's free gain. We haven't amplified anything. But it also could be potentially a problem if you have an explosive vocal right now, because you'd really get a lot of transfer of energy, and I just pegged my meter. So that's an example of that. So let's take it back to balanced bridge and talk about the other thing that this microphone preamp does, and I'm going to give it about another 5 dB. Another nice thing about the stepped inputs, and again, that's 5 dB, this is 5 dB down, is if you're actually tracking and you want to remember and go back and punch in something that you did, and you want to, you know exactly right now that I'm 47, or is that 48 dB of gain, and I could have it be 47 dB. In other words, it's a very accurate, precise way of knowing where you were with that mic in this situation in case you want to punch in and change or substitute a track somewhere. It's very easy for that. Now, the other thing that's unique about ViPre is it allows us to emulate, again, old school basics, blocking and tackling of preamplifier by adjusting the rise time. The rise time is an interesting feature, and it's a bit of a gimmick, I'll be honest. When you look at old mic pre's and why we like old mic pre's, which is a big part of designing the ViPre, we had a very high respect for older mic pre's. We liked the sound of them, but why did we like the sound of them? A lot of people attributed all to tubes, and of course that is a commonality they had, but there's a lot of new mic pre's made with tubes, and they sound a little brittle and a little bright. And started looking at some of those artifacts and found that the support players in a preamp would be capacitors and resistors, and of course transformers if you're lucky, but most new mic pre's don't have transformers. So we started looking at the other components. If you go back to the 50s and the 60s, our resistors weren't as perfect as they are today. Our capacitors weren't as perfect. A lot of guitar players argue about which old capacitor sounds the best, and what they're saying is that they have artifacts in there that they like. They like orange drop capacitors for guitar. Well, they use those same orange drop capacitors in some of the early mic pre's. And of course, we constantly, as designers, wanted to make things with less distortion, less artifacts. But you go back and you measure some of these old resistors and old capacitors. Well, the resistors had capacitance and they had inductance, and that helped them. That contributed to the sound that they had. And capacitors had a certain amount of resistance and inductance, and certainly inductors, definitely inductor being a transformer or a coil or a wire, could also have artifacts. And as we got better at making audio stuff and making precision resistors that were repeatable and film capacitors instead of the older style capacitors, and titanium resistors that had 1% calibration and so forth, basically the resistors have a lot less capacitance and inductance today. They're more perfect, as are capacitors, which have a lot less resistance and inductance. I wish I could say inductors got better, but they didn't really. The old stuff sounds better, but let's just stick to resistors and capacitors, because that's really what rise time is all about. What we're going to do is introduce capacitors and resistors that have these artifacts. And what the nature of those artifacts are is that they slow down the ballistics or the dynamic of the sound. A lot of people talk those older, even solid-state mic pre's sound smoother and warmer. Well, they do, because of the nature of the support components, not necessarily the preamp being a solid state or tube, but the capacitors being 30, 40, 50 year ago technology. They were slower, and so they were a little smoother sounding. Today, most mic preamps are very fast and dynamically fast. They don't really have a slowness to them at all that can be measured. That was something we tried to get, right? But now that we're there, we realize that a lot of these new mic pre's have a lot of sibilance in them. When we buy de-essers to get the S out, and we buy equalizers to trim the top down, and we do all this kind of stuff, and we throw filters over people, have them step back, reach for an old tube mic, all this sort of stuff to try to get rid of some of that ballistics. So the rise time was a nod to that old tube technology, which used old resistors and capacitors. So as I go from my fast time right now, I'm going to show you what happens, and it's almost like going back about 10 or 20 years in technology. And you won't hear it so much in my voice, but I'm going to show it to you on a tambourine. That's, by the way, why we have a tambourine here. So you can hear ballistics a lot quicker on something like that than my voice, which doesn't have much top end anyway. So this is fast rise time, and I'm going to do this kind of quick. Fast, medium rise time, medium slow rise time, and slow rise time. Now on my voice, let me go just real quick from slow rise time to fast rise time, and you'll probably hear the breath and the spittle come up a little bit. If I was going to do a torch song, if I had a bright female vocalist, I might want to go down here to the slow rise time. And I'm not changing my voice. I'm trying not to change my voice. But if I was going to sing something torchy like, with this throat, I don't know. You must remember this. A kiss is just a kiss. So those words have a little bit of semblance, and I'll do it with the fast rise time. You must remember this. A kiss is just a kiss. So a little bit more a top on that, so I go to slow rise time. Now, if I do that with a tambourine, and I'm going to go over here, and actually, you wonder why we brought James in today, because he just looks like he's absorbing energy over here, and he is. I'm going to have you play tambourine real quick.
All right.
And I'm going to change that. I'm going to put the mic on your tambourine real quick. Just kind of right there. Now that's fast rise time. I just shake it a little bit. That's what I want right there. Now I'm going to go down to slow rise time. Now I'm going to go back to fast rise time. Now I'm going to go back to slow rise. Hear the wood come out of that tambourine? Now go ahead and bang it a little bit. That's slow rise time. And here's fast rise time. That's disturbing. That's woody. Okay, enough tambourine for one session, I think. So that gives you a pretty quick idea with the rise time. Now, let's do this Wayback Machine. I'll just try and give you an idea on my own voice. We're going to go from modern, loading it with a balanced bridge, to a 2400 ohm. You'll feel the energy come up, and I'm going to go down to 600. I'm actually going to remove 5 decibels, so I'm not going to fake you out with gain right now, as I get more gain with the transformer, and I'm going to go all the way back down to 600, and then I'm going to go down to 300. And then I'm going to go from fast rise time all the way down to slow rise time. So now we have a mic preamp that has a very soft, warm, slow rise time, 300 ohms. I can be well off the microphone. See how back I can get off this microphone. And now we're going to get, of course, more room sound in here. But the actual sound right now, I can be well off that microphone. Now, if I went back to a balanced bridge and fast rise time, even if I recover 5 dB, I have a completely different sounding microphone out here. And this really isn't about better or worse. This is about different, about taking a single microphone and expanding the potential that you can use with that. If I had a very torchy, bright singer out here, I might want slow rise time, and I might want to leave it at the balanced bridge and bring up an extra 5 dB back here. But if I had someone with a softer voice, I'd probably want to take 5 dB off it, go to 300 ohms, maybe bring up a little medium, and I'd have a very different sounding microphone. Again, now I'm about 24 inches off the microphone. And of course, you'll hear my room resonance come up as well. So that's, in a vocal booth, you wouldn't hear that, but in this room, we have a room characteristic. And so this also is an interesting thing to play with if you're going to use a room mic, and you're looking for more room or less room. Then you might want more of a lower impedance transformer setting on the mic, as opposed to a balanced bridge mode over here, which is going to really narrow out the room and make me work the mic a little bit closer and go to a faster rise time. These are all variables. Now, I'm going to put it on mute just for a second, and I'm going to change microphones. I'm going to show you a mic that you use on stage every day, but with this preamp, it actually becomes a valid recording microphone, and that is the ordinary, this one's probably made in Mexico, Shure SM58. So I'm going to put it on mute. And I'm back on this microphone. Now, you notice the difference between a dynamic mic. You have to really be on a dynamic mic and a condenser mic. I haven't changed gain, but I'm going to show you a little trick now, because we got a lot of gain in ViPre. I can bring that right back up. So I've got up to 72 dB of gain on this mic. So I can now be working a SM58, and I can start to get the kind of gain out of it. You could make it useful. But there's another way to get gain. As I mentioned, it's going to react to a transformer much like the condenser will. So if I go to 2400 ohms, 12, and I get down to 6 and even 300 ohms on this SM58, hey, all of a sudden, I've got something that sounds pretty darn good for vocals and voiceover. And if I take my rise time down and get a little bit of that sibilance off me, you must remember this. A kiss is just a kiss. So there I am again. And again, I'll go back to balanced bridge. I'll go to fast rise time. I'll go to a little less gain. And I've got your same old 58 that we're used to working with all the time. But I can go from that to this just that easily. And even if I get off the SM58 a little bit, you don't usually work at 6 to 8 inches off the mic, but I can, because being it's loaded to something that's a lot friendlier load, it's going to reach out and grab me. I'm going to go back to real quickly, actually, without even going back. I'm going to show you just a couple of the other features. Of course, we have a mute control, handy thing to have. We have a high pass filter, which starts right around 100 and rolls off the bottom end. If you got that, we do have a polarity reverse. So if you happen to get out of sorts with the rest of your signal chain, you can fix that. We have an instrument input over here. When I switch this from the balanced bridge or balanced transformer, we now plug an instrument in here and we can go into the front. So you can leave a keyboard or a guitar hooked up to this. It sounds amazing. The rise time and the tube pre and the on the acoustic guitar piezo, which tend to be very bright. This will really bring out the wood in the piezo using a slower rise time going through the instrument input. And then we have a -20 in case you want to run a keyboard through here that has a little hotter output. You can do that. So that's the way of changing the input from the front to the back. Over here we have a meter range, and what I can do is I can expand my meter range if I have a very soft. Notice the needle goes up. I didn't change my level, but it's going to expand it up. The bottom will come up. Then we go to 0 dB. If I've got a very hot signal, I can go up to 10 dB and 20 dB, and you see it becomes very dead. And so if we want to turn the ViPre down and have a big hot signal come into it, we can actually track it at a much lower level. So normally you'd leave it right around 0. And so then we'll go up to fast rise time. We'll go back to the balanced bridge, and I can just show you with this mic how much different an SM58 can sound. I'll put it back on mute. Just might take a minute. One of the features of all of our mics is we had a slow ramp up. Oh, I want to take that gain down, so they don't when you plug it in, the phantom power, which kind of warms it up, it lets it come on slow. If you unplug one of my mics accidentally and plug it back in, it's not going to go pop. But that's a feature of the microphone. But anyway, that's pretty much the GrooveTubes variable impedance preamp. Thank you, James, for being here with your preamp that he just got. And he's real happy with it. And also, I hope that some of you that might have a ViPre would benefit for some of this little lesson. It's actually pretty basic stuff, but all the things that go in the ViPre made it a very expensive box in a day. It was about $3,500. But there's more hand labor in this. Everything was wired. All the components and the switches and the tube sockets. You know, for every tube socket, you got 9 connections. And there are, I think, 9 tubes in a ViPre. Then those switches have about 200 and 300, relatively speaking, connections per switch. And when you get done putting all this stuff together, then all the other components, there's about 56 hours of hand labor assembling one of these, and it could only be done in China. We actually couldn't even buy the knobs or the switches. We had to make them in China. We had to assemble this in China. So instead of being a $10,000 hand-built boutique one-off thing, we could build them consistently and reliably to all be good, and we could do it at a reasonable price point of just $3,500. But just to give you a perspective on those man hours, about 250 rough to build this and test it and put it through all its paces and all the separate components. There's more man hours in one of these than there is building the typical grand piano. So it's quite an instrument for the studio, and it's unique. And to my knowledge, there's nothing else even today that features 5 different ways to load your preamp, 5 different variable signal path rise times that you can apply. That is a true balanced mic pre, front to rear end, not just balanced in and balanced out with a single-ended signal path, and that is fully floated and differential. And I'm kind of proud to say that after having not built these, now we sold the company to Fender in 2008. That's pretty much the last year we built a ViPre. Most of these are still out there. You can get service on them. One of our good friends down in Orange County, I think he went down, saw Paul Molarty. Paul Molarty Technical Services would be a great place to get advice, parts, and if you can afford to send him one, he actually has an audio precision test machine down there that he can, I think you told me that he had ran it against his golden sample, and this one came out perfect. So there's an ongoing way. Fender was very wise to allow Paul to have all of the test gear from our company at that time, and also a lot of extra parts, so we can have an ongoing service effort for these. Finally, I guess there's not much more to say, but thanks for watching, and we'll see you later. Aspen Pittman, James Abke, signing off from Aspen's Place Recording here in the wonderful 2.4 square miles of heaven we call San Fernando, surrounded by Los Angeles. Bye.